I asked you last week when would you like a revision lecture and if it was a good idea. Most people said yes. So I thought that could be today. Okay, any objections? Anyone going to get angry? Okay. All right, hello. Hi. So, what I thought we could do is look at the algebra questions. I'm going to do them in random order. Okay, if John Steele wants to do calculus, that's up to him. But I don't want to sort of cut, eat his lunch or cut his grass or whatever. But what I can say is I do have two unreleased videos from previous years covering calculus and algebra. Are people interested in seeing those? Yeah? Okay, all right. I'll send that out maybe tomorrow, today or tomorrow. All right. So the practice exams are on Mobius. They're on Mobius. All right, so let's get to it. You can help me solve these problems. Now, one of the things that you've probably noticed if you've done the practice test. Please have a look at the practice test. Can I have a show of hands? Okay. Did you notice some of the questions are kind of repeated? The style of questions? So what I've done the hard work for you. I've sort of picked out one of each of the different kinds of questions and I thought we could discuss them. Okay? The only thing that's going to be different between what you see today and your exam are the numbers. And it kind of depends what set of questions you get. Like let me give you an example. I'd be very, very, very surprised if anybody here got 2 inequality questions from calculus. You probably won't get 2. You get 1, maybe none. Okay? So let me just step everyone through these. These are not particularly hard, but you don't have a lot of time to do them. Right? So let me turn that down. So you don't have a lot of time to do them. 15 questions, 40 minutes. It's like 2 questions. 2 minutes per question, 2.5 minutes. Okay? All right, so let's have a look at these questions. Some of you will be very straightforward, others maybe you haven't done them yet, that's okay. Practice with the time test as well, right? So even if you do a time test on Mobius and the time runs out, I did one today, I just couldn't be bothered finishing it, you'll get a fresh test in 40 minutes. So you can do infinitely many. Okay? So let's have a look at this question here. We've got a PVF. It's in 3-dimensional space. And you've got a plane. Okay, so a line and a plane. The question is, for what value of the lambda, do we get notes on the day? I think you do. I think you have access to the calculus and the algebra notes, either as a PDF or as hard copy notes. Okay, that's a really good question. Should you bring a pencil or a pen? Yes. Do you need to bring your own paper? No. Calculators? No. Student ID? Yes. Phone? Yes. Okay. If you don't bring your student ID, driver's license, passport, something like that. Okay? All right, so the question is, really what they're asking you here is, what is the value of lambda that makes these two things touch? Okay? So, you've got a plane and a line and they're going to touch at a point. What's the value of lambda? So, can anyone suggest how we might start this problem? Yes? Yeah, so the suggestion, which is an excellent one, thank you, is plug in the x, the y, and the z values into here, right? That'll give us an equation involving lambda. We can solve it and get a value for lambda. There should only be one value, right? You can see from the picture at least in this case, it's only going to touch at one point, right? So here we have x equals 0 plus lambda times -1. So y equals -1 minus 1 lambda, and z equals 1 minus 3 lambda for our line L. Okay, and then for our Cartesian plane, we'll sub it into P. Okay, so we'll get -x plus 3 times that plus 4 times that equals 33. So really that's what you want to solve for lambda. It's just a linear equation. You balance it up. You can use maple solid if you want to. It's up to you. Okay, so rearrange the lambdas. And I think the value of lambda is -2. Okay, so expand the brackets, rearrange, and you're all good to go. Yeah, you'll be able to see the recording, right? So what most people do, people are asking, will be able to get the notes. Just look at the recording. People take screenshots. I think that's the best way to do it. I know some people say, oh, I want a PDF of everything you've written. I think I'd be more comfortable if you did that than me. Yeah. So what would the solution here be? Lambda equals 2. So what is how would we find the point of intersection? That's the lambda value. But how would we find the point of intersection? Yeah, so we're asking us, yeah, that's right. But I'm saying if it asks you for the point, so this is right, -2, sure. Yes? Yeah, exactly. So if lambda equals 2, my point of intersection is just, 2, -1 plus 2, 1 minus 3 times -2. So if they ask you for that, that's how you can get it. But they don't ask you for that. Okay? How's that on the difficulty scale? Not too difficult, but it's hard if you don't know where to start. Like with these kind of problems, people are like, I don't know where to start, because they haven't seen a problem like this before. It's okay. Did you add comments? It's okay. You don't have to do it. I was wondering if anybody would actually tune in. That's okay. That's good. I prefer that. Someone asked me, do any of the people in the room tune in? I'm like, I don't know. Let's look. All right. Any questions for that one? Yes.
Intuitively, why is it the point of intersection when the two equals?
Well, that's essentially what's happening.
Why subbing in lambda for your Cartesian value, your PDF, does that give you the point of intersection when it has nothing to do with the Cartesian?
But it does, because the question is why does the parameter in the parametric vector equation have anything to do with the Cartesian plane, right?
I know to do that from rote length, but
yep.
I don't actually know why.
Well, you want to say, okay, well, can we find the value? So here's an x, here's a y, here's a z, right? So that point will satisfy the equation of the plane as well. Okay? Yeah. So this is the point, x, y, z. So it satisfies both the line and the plane. All right, cool. Oh, this is always a good one. Yeah, the point of intersection, just sub in -2, lambda equals -2, something like that. All right. So this is an interesting one because it's a little bit different and you might have to make some adjustments to your strategy with this one. Okay? So this is more potentially annoying than difficult. Okay? And I'll show you why it's a little bit annoying. So you've got a plane and you want to express it in the parametric vector form, the PVF. Okay. Now they give you one vector that's parallel. How nice of them, right? This is parallel to the plane. And you have to come up with a position vector, vector to a point on the plane, and a second vector associated with the PVF, right? Now, the danger here is when you're doing this question, you come up with a V2 that's a multiple of V1. That's the danger. Okay? That's the danger. Because they're just sort of the same kind of vector then, aren't they? They're not non-parallel to each other. That's the danger. So, when you're substituting these things in, as I'll show you how, just keep that in the back of your mind. Okay, so let me show you what I mean. So, with these ones, I'm going to sub out I'm going to let x2 equal lambda. And x3 equal lambda 2. Okay? Now, theoretically, you can put in you can substitute out any variable for any parameter that you want. But watch what happens when I do it this way. Okay? What I would hope is with these substitutions, I'll sort of naturally get that and something else. Okay? All right. So, if that's the case, this thing is going to be, well, let's just rearrange it. x1 equals negative a half, and all this mess. 9 minus 2x2, which is that, plus 5x3, which is 5 times lambda 2. Okay? So we've actually solved the question now with that, and that. Okay? So how do we come up with these magic vectors that they want us to come up with? Well, I'm glad you asked. Let's write x1, x2, x3 as a column, and we'll sort it out. Okay, so x1 is this mess. So negative 9 on 2 plus lambda 1 minus 5 on 2 lambda 2. x2 is just lambda 1. x3, lambda 2. That actually contains the answer, but it's not in this nice PVF form, right? Okay? So let's write it in this nice PVF form. Okay? Take out the constant vector. That's a 9, believe it or not. Take out, now this is the point where you go 1, 1, 0. Oh my God, it's the same, I'm on the right track. Okay? That's it. These questions, where can you find these questions? They're on lab test 1, all algebra questions on Mobius. Question.
Am I correct that an alternative method of doing this question would be to take, say, x and y equals 0, solve for z, call that point 0, 0, whatever z is, and then find another point, just subtract 1 from the other.
Yeah. You can do that. You can do that. Is that going to be in the form that they want, though?
Yeah.
That's the risk. That's the risk. Because if you do that and you get, I don't know, like some other vector, some multiple of this down here, obviously these two things, they can't be multiple of each other. So that's the risk.
But as long as you check that.
Yeah, you should check it. So who can tell me why are these vectors not parallel? Who can tell me? Yes?
The zeros.
Yeah, the zeros, right? They're not a multiple of each other, and there's a 0 here and no 0 there, 0 there, no 0 there, right? So you cannot multiply this in any way to get that. It's just not possible. Okay? Now, what happens if you make the wrong substitution at the start and it screws you up, go back and redo it. Go back and redo it, because I'm not convinced that different substitutions will give you what they want you to get. Okay? Other questions? Yes?
Why is lambda equal to, how can we set lambda as the different x values? Like what link does lambda have with x?
Well, what we're trying to do, right, is to express x1 in terms of lambda 1 and lambda 2, x2 in terms of lambda 1 and lambda 2, and x3 in terms of lambda 1 and lambda 2. Okay? In order for that to happen, we have to sort of make some substitutions to get things to work. Okay? So that's really what parametric vector form is all about. It's about, you've got these variables, x, y, and z, x1, x2, x3, but let's write them all in terms of some shared parameter lambda. Okay? All right. Oh, by the way, I probably didn't tell you this. One of these revision videos that I'm going to send you, somebody on the chat said, "Oh, you should do ASMR because it's so great for sleeping." You know, one of them is an ASMR video. I'm not kidding. One of them is. So let me know what you think. It's even in the title. Hey, yes. Yeah. I think so. Yeah. I don't think so. Try it. Try it and see. So there's a good question. The question is, let's say I let x1 equal lambda 1 and x2 equal lambda 2. Will I get the same? You'll get a different parametric vector form. Will it have one of these as your parallel vectors? Probably not. Check it. Okay, why did you let x2? Because I wanted to get something that incorporated this. Okay? Where did the half? Just dividing by. So negative 2. You want to make x1 the subject? Divide both sides by negative 2. Okay? A is a point on the plane, right? So the position vector, so you've got a plane. Here, here's 0. That's your position vector. Okay. So basically that's a vector that gets you from the origin onto the plane. And the other two vectors move you around. That's all it is, right? Okay. Let's do another one. It exists, it's just a private video for you only. Okay? That's it. It does exist. If there's a good reaction, I might release it. I don't know, I might get cancelled if I release something like that. You know, some student got really angry with me this morning because he was asking me questions in the tutorial and he wanted me to show him how to use Moodle. It's like, I don't know how to use Moodle, can you teach me? I don't know, hey. I don't know. All right, something a little easier. 3 points. You've got to drop down boxes. Let me just zoom in a bit. I won't teach Math 1, 2, 3, 1 next semester, but I have about 500 videos on Math 1, 2, 3, 1. So, yeah, I'll send you a link. So this is one of the starting entry-level type questions for the algebra. 3 points. Is AB a scalar multiple of BC? And then there's a test for collinearity. Okay, so let's have a look. So I wouldn't do this in Maple, right? It's the position vectors. Okay, so what am I going to get? 2, negative 7, 7. And BC, that's going to be C minus B. Okay, so negative 11, 21, Okay, so the question is, are these vectors a multiple of each other? Are they parallel? Yes or no? No, they're definitely not. If you look at the two coordinate sort of entries down here, it looks like it's okay for this one and this one, but this one stuffs it up. The top one stuffs it up, right? So you have to have the same scalar multiple for all three cases. Yeah? So is not 3 points are they collinear? No, not collinear. Okay, this is my handwritten drop-down box. Yes, question. No, it doesn't. So the lambda could be negative, could be positive. At least it's just one lambda. Okay, hello, that's all right. Welcome. Other questions? Pretty entry-level type of problem. Okay, you should do that in under a minute, I reckon. Oh, move the page down. I can't see the top. Okay. There, how's that? All right. Do they pre-open Maple for us? That's a good question. I don't know. What somebody asked me today is the 40 minutes from the time you enter the room or from the time you start the test? I would hope that it's from the time you actually start the test. So you should log in, you know. Yep. I don't think there is. I don't think there is. I think they're just going to draw off what's up there. Okay? Yes. Open book in the sense I think you're going to have access to all the notes in terms of the course pattern. Okay. Oh, I'll zoom out a bit for this one. All right. Ooh, this is a parallelogram type question. You probably saw many of these. These are not difficult, but the thing that people miss is this thing here. The order. Order matters. Okay? The order matters. Okay, people go, oh, it's A, B, C, D. No. In this one, it's A, D, B, C. So what I like to do with these ones is to actually draw a picture and label it, just so you know what's going on. Okay? It's not a difficult question, but yeah, it's not a difficult question. So what have we got? We've got 4 points. We want to find the vector from O to D, which will tell you where D is. Okay? So the way I did it, A, D, B, C. So as you rotate, you go along the letters. Doesn't matter which way you rotate, I'm going to do it this way. Okay? So if I just roughly draw that in, I want these two sides to be parallel and these two sides to be parallel because it's a parallelogram. And where shall I draw the origin? I'll just draw the origin over here, close to D. Doesn't matter where you draw it, right? So if I want OD, what I can do, I can go from O to A and then A to D, and AD is the same as CB, right? Okay, so right, AD is going to be equal to CB, which is the negative of BC. Okay, and I know what BC is. It's over there. Okay? So just by drawing a little picture, I can sort of get some idea of what's going on. Okay, so CB is going to be negative of that. Okay, so to work this one out, it's just going to be OA, which is that. Oh, hang on, have I got that the wrong way? CB. Sorry, plus CB. Oh. Okay, so simplify that and you will get your answer. You can definitely dispute it. In the lab test, if you make a mistake, you can dispute it. I don't know if it'll get you anywhere. One thing that I've seen in previous years is potential copying and pasting, either between Maple or somewhere else, maybe from the notes. Don't do that. That's a recipe for disaster. Just type whatever you can, especially things like open and close brackets for intervals. Just be really careful. Just type them in, okay? Because it'll say, someone will say, hey, I got the right answer, and it's like, well, you've entered something funny there. It looks right, but Maple doesn't recognise it. So, no, Mobius doesn't recognise it. I know. I would be upset too. But you can always dispute it. You can always dispute it. So, yeah. Okay, so any questions for this one? Okay, great. How do we know? Oh, I missed that one. I'll come back. Okay. How do we know our calcs are approved? You don't need calculators. You won't be able to bring them in, unfortunately. Maple is your calculator. All right. This is a classic one as well. Now I'm going to show you a few extra steps for this one. Just because some people ask about the ratios of two vectors. So let me show you what I mean. We've got the 3 points. And we're told that there's this point T that lies on the straight line through A and B such that AT equals TB, 3TB. Now, something interesting here, why would, if this looks like this, yep, what's that doing there? Any ideas?
Doing an abstraction.
It's a distraction. I think it is anyway, unless I'm missing something, which might be possible. It's a distraction. Okay, so the way I like to do these questions is I'll actually draw a picture and I'll say, okay, I want that vector there. Okay, that's like your T position vector. And to get there, what I can do is add those blue vectors. And so how much do I add with that second vector? It's contained in here. Okay? Maple, love it. All right? So OT is OA plus AT. Now, this is just the same as this. Now, people freak out when I write that because they're like, well, how did you get that? So let me show you. Okay? How did I get that? How does this imply that? Well, you're kind of splitting, like this is sort of split up into 4 bits. Okay? So 1, 2, 3, 4. Okay, this takes you sort of 3/4 of the way, and then you've got another quarter left over. Okay, that's basically from this ratio. But let me say something else. I'll sort of just justify it a bit more. Right? Would you agree that this is true? To get from A to B, you go AT and then TB. And then you can replace one of these with this. Okay? So I'll write it in terms of AT. So TB is just 1/3 AT. Right, so that's from there. Yeah? So 4 on 3 AT. So you rearrange that and you get AT equals 3 on 4 TB. Okay, so if you're ever worried about it and you're not sure, from the diagram you can usually work out the ratios. Okay? When you've done like 5 or 10 of these, you don't even think about it. You know? So what I can do is I can say, right, I'm going to replace AT with something I can calculate. Okay, because I know A and I know B. All right, so I'm just going to keep going down here. So OA plus 3/4 that. And I can calculate both of those. Right? So it's going to be -9, -6/0 plus 3 on 4. So what is AB? Well, the vector 8, 6, 4. Yeah. So what do I get for AB? Oh, good. 17, 0, -3. Thank you. Okay, so all we need to do is simplify that. Put it in. Now, if I was doing this question, would I simplify that? What do you think? Would I simplify that? No, there's no reason to simplify that. Put it into the Maple box. Maple will simplify it for you. Okay? You've got 2.5 minutes for each question. Okay? If you look at all, like I say in my tutorials, over most weekends I just play around with Mobius, right? And if you look at the text boxes that I've entered, because they're saved, almost none of them are simplified. I know in maths we say, oh, always simplify, but here it just doesn't make sense. Right? Yep. Yes, so that's a great question online. You know how in Maple at the bottom they say make sure it's in Maple syntax? Yes. That they will expect you to enter it in Maple syntax. Okay? Smashing it to the wall. Okay. Any other questions? Any other questions? Okay. So, okay. Question.
Yeah. So how we have to deal with the negative coefficient of minus dp? There was some question like how.
Oh, so that will be so that will be when the point lies outside. It doesn't lie between the 2 points. It lies outside. Yeah. So draw a picture. That's the most important thing. Yeah, that's a really good question. And in fact, I'm pretty sure one of my videos might cover an example like that. Okay? All right. Dot product, cross product. Now you could use Maple for this if you want to. It's up to you. Yes? Well, it's going to be something like this, right? It's going to be... So if this is a negative number, it's going to be something like maybe like that. Can you just look at the ratios between the two? Does that make sense? Yeah. All right, so dot product, cross product, pretty easy. Yes, question.
You know how sometimes the point key is exterior to the line?
Yep.
How do we know if it is?
It'll tell you. In the question it says they're all collinear. Right? Yeah, we wouldn't ask you if it wasn't on the.
No, sometimes it's like A and B and then P is not between A and B.
Yeah, that's what we're just talking about. Yeah, with the negative coefficient. Yeah. All right. So dot product, cross product, two vectors, happy days. Right. So u dot v. Okay. So what are we going to get? 14 minus 30 plus 28. Do you need to simplify that? No. You can if you want. Yeah, what does it simplify to? 12, something like that. Okay. And the cross product, the way I do it, I play cover up. But if you want to use the, the maple command, that's fine. So you don't have. Oh, so there's paper. There's paper. So you need to bring a pen if you want to do it. So I suggest expanding along the top line. So I times the determinant of that minus j times the determinant of that plus k times the determinant of that. Okay, that's how I do it anyway. So what are we going to get? 24 plus 35 minus negative 8 plus 49. And you've got to change the sign. And then 10 plus 42. Okay. Yeah, it still works. Try it. So somebody on Maple, on the live chat saying it still works with 40 minus 30 plus 28. Yep, it should do, because Mobius simplifies it for you. What's the Maple? Oh, someone's
Just type out cross product.
exactly. There's a shortcut. It's ampersand and times. That's a shortcut as well. So yeah. What is it? Let's have a look. Yeah. Instructor indoors. Okay. There should be enough. This is a really good question. Does the computer lab have enough space for paper on the desk? There should be enough. I would think with COVID, they probably have moved their machines a little bit further apart. At least I would hope they would. But my advice, go to the computer lab and find out. And if it's not wide enough, let us know. Because you could say, well, it's a COVID risk, right? You could. You could. Did anybody hear about what happened with Math 1141 today for their lab test? Power cut. Oh, what a shocker, hey. So there's like 300 students trying to do an exam and all the power goes out. If that happens, what do you think should happen? What do you think should happen? I think they should be given 100%. No, they'll have to do another test, unfortunately. Maybe they should be given 100%. Anyway. Yeah, that's right. Oh, it's so funny, right? I talked about I talked about air conditioning and how, you know, I was talking about Soviet Russia and how my colleague said, because my office is 30 degrees today, right? I don't have air conditioning in my office. Right? There's, you know, my Russian colleague said, it's like Soviet Russia, they treat the machines better than the people, fine, okay. Yeah, it's like, and also some of my Chinese colleagues come over from China, and they go, and they have a look around the uni, and they say, oh, our university's entered the first world. I think your university's gone back to the third world. Like, you're not lying. Anyway, any questions for this? Pretty straightforward, right? Dot product, cross product. Okay. Yeah, the Maple Tips and Tricks video will be... I think I've already posted one of those. Have a look at the announcements. What do you need to know to solve these kind of problems? Even calculus. Plot, limit, what else? Solve, eval. They're pretty much all the commands you need, especially for the calculus. If I was doing this test, I would be doing 0 questions with pen and paper. I would just be doing as many as possible with Maple. Okay? All right, so let's have a look at this one. You got 2 points. Find the parametric vector equation, enter A and B, and then they ask you to verify or not that a point lies on the line. Okay? So, who can tell me how can I get a vector V given 2 points? Yeah. AV. Okay, you don't have to write all this down, of course. Okay, so 24, 30, thank you, negative 18. And does it matter which point I choose? No, it doesn't. Hopefully Maple knows that. Okay. All right, so the vector OA would be that. Okay, now, does the point C lie on the line? For Maple, do we need to know plain text or 2D math input? I mean, I would say the math input's the most important. I don't ever use plain text unless I'm commenting something. Yeah, there's a few. It's up to you. Like, what do you need to know for this? Lab test 1, what commands do you need to know? None. But you can use them if you want to use them. Okay? All right. So how can we check whether or not this point lies on the line? Well, let's write it out. This is the PDF. Okay, and so what we would do to test it is say, hey, that's going to be my X, that's going to be my Y, that's going to be my Z, plug them in here, and then see if there's a lambda that makes it work for all 3. Okay, so okay, so you think, okay, well, what's the easiest part to solve? Be this one, right? So what's lambda going to be from that last line? Negative 2. And I'll put a question mark there because does it work for the other ones? You add, that'll be negative 60, so that'll work. And then that'll be negative 48, so that'll work. Yeah. So does it? Tick. Okay, you want one lambda to work for all 3 equations. And if you get different values of lambda, there's no way the equation can hold. Okay, so this is a pretty easy one, but there's just a few steps. Questions? Okay, where's John Steele? Is he around? Yes, question. Yeah, it does. Because you get negative 48 equals 24 times lambda. So what does the first, that's a good question, what does the first row, you take that to the other side, this becomes negative 48 equals, yeah, I know, it's easy to make a mistake, I do it all the time. Okay? So one of the great comments I saw the other day was time to get negative 150 likes. That was pretty good. So because you'll see some of these ones have negative likes, which is kind of fun. All right. It's the same one. Power projection. Okay, so I don't have time to fully solve this one, but I will just give you an idea of how to do it. Okay, projections are not very well understood, I've got to say, with a lot of students because they're hard. You've got to think spatially, you've got to keep track of things. Okay, but for this one, you've got 2 points and a given vector, and you're told the vector between P and Q. How good is that? L's a straight line through P, so you've got bloop, 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 and you've got some sort of vector. Okay, who knows where it's pointing, but it's parallel. Okay? Now, Q is another point that's not on the line. Okay? And bloop. What you want to do, what this question is asking you to do, is to compute, let's call that Z, is basically to compute the vector Pz. Okay? Now that is just the vector projection of PQ on V. Okay? I know projections. All right, so what do you need for that? You need a dot product, you need some lengths. By the formula. How do you get the shortest distance between the Q and Z? Pythagoras, right? So that's that one. And then that's QZ. You want that distance from there to da, da, da. Okay. So that's what you want. Okay. No complex. The best way to understand what's in the lab test is to do the practice exams. Okay? All right. Let's leave it there. Good to see you again. Hopefully I feel a bit better tomorrow. We are going to do complex numbers tomorrow. Just one thing. You want to be aiming for 100% in this exam. 100%. Okay? Like it's easy marks. Anything under 16 out of 20 is like, it's not a good sign. Okay? So you should be getting more than 16 and you probably should be getting 20. You can do it. I know you can do it. Okay? And that's 15% of your final grade. All right, so if anyone has any questions, come on down and I will see you tomorrow. And yeah, thanks for everything.